Welcome, everyone. I hope you're having a good day so far, that everyone's staying safe. Thank you for joining me, and thank you to RH Moore & Associates for setting up this webinar so that we're able to get together today. My name is Sam Justice, and I'm one of the engineers at Presto Geosystems. We manufacture erosion control, stormwater management, and porous pavement products. We're located in northern Wisconsin and work closely with RH Moore throughout Florida on a wide variety of projects. Most of you know the great team at RH Moore, so we're going to dive right into the presentation so that there's enough time for questions at the end. The focus of the presentation is on designing stormwater channels using the GEOWEB Channel Protection System. So here are some of the things that I hope you get out of today's presentation. Understand the research performed with the GEOWEB Channel Protection System, how it can overcome typical problems and a variety of uses, including specific uses related to high flow situations. During the presentation, if you have any questions, please type them in the chat window and I'll answer them after the presentation. Everyone's phones will be muted until that time. So we're going to start with some protection and break apart, severely limiting their lifetime use. Rock nets are used to hold riprap to steep embankments, but if they're not anchored properly or if they become undermined, they can fail catastrophically. Poor construction techniques can lead to channel failure. The more difficult the installation of the channel, the higher the chance of failure due to construction issues. And not all infill materials are up to the task. If there's going to be differential settlement along the length of the channel, you don't want to choose a highly inflexible protection method. Poor water pressures can build up underneath concrete layers, and if they're not relieved soon enough in a proper manner, they can cause uplift and cracking. And if the channel cannot handle the flow velocity or shear stresses that it sees, failure is inevitable. This is why design loads should be conservative and verified. Now, with all of that refreshed in our minds, we'll move on to describing the GEOWEB 3D system, velocities, erosive conditions, and hydraulic stresses. The GEOWEB system container size. Cell is very important to the function of a geocell. The stronger the seam, the better designed a geocell is. A strong seam allows for heavier infill materials, steeper and taller slopes, and better lifetime performance. The strength of the panel material, which in our case is high-density polyethylene, HDPE, is also critical to the strength and performance of a geocell system. Here you can see a typical GEOWEB panel. It comes tri-folded on a pallet and can be delivered directly to your project site. Each section has a nominal width of 8.5 feet, with lengths up to 32 feet. The panels are flexible, opening like an accordion, so they can follow the natural contours of the work site without being confined to a rigid set of dimensions. The second main attribute of the GEOWEB components interact with we have our channel with some standard dimensions. The first thing to go down is the geosynthetic layer, which can be a geotextile, a geomembrane liner, or any similar product. Then the GEOWEB panels are put in place. Note the panels have a horizontal turn near the top of the side slopes. This is important for crest anchorage and erosion control. We have two options for anchoring. One is to use stakes or earth anchors. These are placed mid-side slope and at the crest. The number and spacing of the stakes is going to be project dependent. The other option is to use tendons and a dead man, with the dead man being either a buried pipe, a concrete anchor, or earth or rock anchor. Concrete is going to be the first component for a completely integrated system, connecting each individual, and that the GEOWEB system will not fail. Side slope angles increase. The driving force of the infill material exceeds the available frictional resistance required due to project conditions. If maybe you're in a saline environment, Presto has an HDPE ATRA speed stake that's designed to work with the GEOWEB system. For steep side slopes, a channel where the native soil is highly erodible, membrane liner, tendons can be used. The ATRA tendon clips transfer the load from the heavy infill material to the tendons and then the crest anchorage system. Using the 3D is much more. Each flexible cell is protected against erosive force, such as erosion control blankets, ECBs, protect the channel from hydraulic forces of the water. and so the channel may fail, even if the 2D solution is still in place. Single layer system, where the GEOWEB panels are laid directly on, think 45 degrees or shallower, as long as there's room for these side slopes to be laid back like a house in this photo. In cases like these, to create a retaining wall on one or both sides of the channel bed. These retaining walls can withstand the same velocities and shear stresses and are still flexible enough to handle curves and changes in grade. So here's a list of them. These applications are obviously all channel related, but there's still a variety of ways to use the system when it comes to protection against water flow. It's important to note that the system can be used to protect an entire channel, that is, the channel from the crest to the toe. So there are two types of. This soft armoring allows for vegetation is in place of riprap, allowing for natural looking areas such as roadside ditches or drainage swales. The GEOWEB protected areas can be mowed with a standard lawnmower, so they're not going to affect the regular maintenance of roadside areas. We performed extensive testing at Colorado State University. Vegetated channel testing was performed with two standards of success in mind: the ability to withstand water flow and the ability to reduce topsoil loss due to that water flow. The set included the 6-inch deep GEOWEB panel covered with a turf reinforcement mat, a TRM, and then it was seeded with grass. 10 blades is important for a healthy and cohesive appearance. Vegetated channel could handle that much water, but when properly confined in the GEOWEB system and with a TRM overlayment, velocities of 30 feet per second are no problem. Using a hardier variety is going to improve these results, and it can still blend well with the natural grasses around the channel area. Here's a quick comparison to show how great these results are, since it can be difficult to visualize what 30 feet per second really looks like. What we see is that the GEOWEB plus TRM system far outperforms any other option in both allowable velocity and allowable shear. The key results here show that the GEOWEB filled with topsoil provides the same protection as 12-inch riprap and also doubles the performance of a standard TRM or ECB in vegetated conditions. So we have a case study for the GEOWEB vegetated system. A canal through the city of Opelika is a floodplain that was experiencing heavy sediment erosion, significantly reducing the volume of the stormwater runoff through the canal. The side slopes of the canal were regraded to eliminate areas of previous failure and getting the site ready for the installation of the GEOWEB system. A non-woven geotextile was laid out to help protect the highly erodible soil during the installation process. The GEOWEB panels were laid at the crest was also small, just enough to bury the top of the GEOWEB panels. The panels extend slightly into the water below the normal water line, so that the protection extends below the water, avoiding a potential scour area. The flexibility of the GEOWEB panels is a big plus during the installation process, making it easy for the workers to maneuver around. The excavated top is a great way to save on material costs and to know that vegetation is going to grow in the system. Using a front-end loader is an easy way to move the soil. The equipment can dump the soil in large piles, and workers can then rake the soil into all of the cells for composting, getting about 1,000 square feet of the system installed per hour with a 4-man crew. And here we can be capable of withstanding the high water flow during storm events. This was a fast and easy solution to a significant erosion problem that's going to last the least needed, but with GEOWEB retaining walls in place of side slopes. Here you can see repair of severe erosion at the bend of a channel. A multi-layered channel system on one side of the channel was built and vegetated. When GEOWEB protection is on both sides of the channel, the horizontal footprint can be built extremely narrow, allowing room for additional stormwater to mitigate flooding potential. This is popular in residential areas where people don't want to give up half of their backyard to stormwater channels. And it's absolutely possible to mix vegetated GEOWEB protection systems with other common solutions, such as stone blocks at the bottom of the channel, which can help prevent scour. We're happy to discuss the GEOWEB earth retention system in more detail for specific projects. So I'm going to pivot for a minute here. The first type of permeable channels can be installed where high rain falls in channel side slopes into the natural groundwater to significantly reduce aggregate size, which is based on some extensive testing that we're going to cover in a minute. Also, the ability to resist higher velocities and shear stresses due to the confinement of the aggregate, and the ability to use poor quality aggregate materials. Poor quality materials can include waste rock from blasting activities, local material that's not been specifically graded, and many more options. Using smaller aggregate replaces the need for larger, more expensive, more difficult to obtain riprap. Unconfined aggregate channels are somewhat rare because they're difficult to design and require expensive, difficult to place stone. Using an aggregate-filled GEOWEB channel protection system, it's easy to design and easy to install. Save on material costs and shipping. Just use what you have on site. So again, we partnered with CSU for testing of aggregate-filled GEOWEB channel systems. Tests were performed with varying water flow and bed slopes, and with 2 different aggregate sizes. A non-woven geotextile was placed underneath the GEOWEB panels, but no surface protection was used. No geosynthetics and no grouting of the stone. We looked at how well the aggregate stayed in place during the test to determine the rock size that would not wash out, post-installation maintenance required for these systems. So the results are pretty good, with the GEOWEB system working on a steep bed slope and allowing a decently high velocity. But if we remember back a few slides when we were talking, so a vegetated system is actually stronger and can withstand higher flows and shear stresses than an aggregate-filled channel. This may seem counter to the strength of a whole lawn of properly rooted grass compared to a single 2-inch stone. It makes more sense. Now, this isn't to say that aggregate channels aren't useful. They definitely have their place, especially in more arid environments or where stone is readily available, such as mine sites. If the flows can be withstood by either infill type, it becomes a question of aesthetics in the end. So what came out of all of the testing additions at the site? The professor and grad students came up with a complicated result. What it came down to is this. We can recommend the appropriate cell depth and rock size to wash out after the first rain event. So now I have a case study to show the aggregate-filled channel in action. This project was at Legends Field in Tampa. They need to restore several ponds that are located around the field, which were also part of the area's stormwater mitigation plans. The water level in the ponds were low and existing vegetation was removed to allow for regrading activities instead of replacing the vegetation because the water levels in the ponds were subject to frequent fluctuations, which is not ideal for growing grass. The shallow slopes allow for very limited need for anchorage, with stakes being used to hold open the panels during installation, to ensure that there's no potential leaks of the pond. Panels are easily able, as can be seen here, so the sites can be customized to your specific needs and regulations. It's also good to note that heavy trucks and construction equipment can drive on the GEOWEB areas immediately after infilling as an access road for construction, even all the way up. This way you can limit the amount of excavation or temporary buildup on sites because you don't need additional access roads when you can simply drive on the GEOWEB system. And here's the final product. An aesthetically pleasing rock was used and integrates nicely with the surrounding vegetation. The GEOWEB panels are visible, but now the ponds can handle water level changes without needing to worry about dead grass or erosion concerns. With the aggregate protection system, there's little to no maintenance required here. Since the aggregate is confined, it won't need to be replaced, and it doesn't interfere with your standard landscaping maintenance. So our second type of hard concrete-filled channels are most beneficial GEOWEB channel applications. The GEOWEB for curves, dips, and other features of the landscape to be incorporated into the channel if desired. This allows for a more natural-looking channel and limits the amount of prep work required before construction can start. Because the GEOWEB panels act as the formwork for the concrete, they can also act as internal reinforcement. This means no additional reinforcement is necessary, no laying rebar or using fiber reinforcements. The unique aspect of the concrete being poured into the individual cells means an easier to pour, higher slump concrete can be used. The slump can be adjusted in the field as necessary to handle different slope angles, even near vertical angles around culvert outlets. In general, 3 inches of concrete-filled GEOWEB protection replaces 5 to 6 inches of reinforced concrete. And compared to articulated concrete blocks, ACBs, the GEOWEB system is both cheaper and safer to install. Costs are 2 to 4 times lower than ACBs, and no heavy equipment is required to lift the GEOWEB panels, so it's safer for workers. Again, testing was performed on channels. Here, a single phase was run. The test maxed out the flume at a block underneath the concrete-filled GEOWEB sections, indicating that this is an excellent system for protecting channels against soil erosion. The GEOWEB system is the only geosynthetic, including ACBs, TRM, ECBs, etc., to ever max out the test flume at CSU. So we're very confident that it will work for even the most challenging projects. So this was a project for a wastewater diversion channel from a mine in northern Mexico. The channel would be used infrequently, but expected flow rates were very high. The channel followed the contours down the mountainside, so there were naturally a lot of curves and corners. Those are the places where turbulent flow is most common along these types of channels and turbulent water forces. So concrete infill was the right choice for this situation. A unique aspect of this project, inlet channels, converge designs, formwork, reinforcement, and anchorage for each channel, the GEOWEB's entire channel network. Because the GEOWEB panels are the formwork and reinforcement, it vastly decreases the amount of installation work and cost of materials. The concrete is poured direct and is usually hand leveled to the top of the cell. This way, all of the concrete is confined and protected, and you can guarantee that the channel will have a consistent concrete depth. Concrete can be poured into sections like you see here, without losing strength or having seams. The GEOWEB panels break up the concrete so it does not need to be a single monolith to have sufficient strength, so you don't need to pour all of the concrete at once. This is especially helpful in areas that are far from a batch plant and transportation may be an issue. Again, we're following the rule of filling the GEOWEB panels from the crest to the toe or the channel bottom. The channel is anchored with tendons, which are keyed into competent rock on either side. If we remember all the way and where buried pipe deadmans are placed. Here, the GEOWEB panels are filled with concrete into the trenches. The client decided to use local boulders as energy dissipators rather than using preformed structures. The original concrete was poured over them to integrate them with the GEOWEB system. It's not the prettiest approach, but it definitely gets the job done. And adding energy dissipators to your channel can be a great way to quickly reduce your flow velocity if the channel is going to terminate in sensitive areas, such as a wetland. If there are questions about incorporating dissipators into the channel system, ability of design, and a variety of infills to meet your, and this is a complete system solution for ease of installation and peace of mind. Backed by extensive, including myself, we do offer that free project design evaluation through a form on our website, prestogeo.com. You fill it out with as much information as you have, and you can include attached documents such as geotechnical reports, and it gets sent to us. And usually within 3 business days, including anchorage requirements and geotextile recommendations. We're going to work with you to get the best. So my contact information is here, or if there are any questions that come up later, and there's info for RH Moore, who you're going to go to if you have questions about pricing or local support. A follow-up email will be coming to you in a few days, so please keep an eye out for that in the future. And you've also earned a half PDH credit for being here today. The follow-up email is going to give you instructions on how to receive your certificate, so definitely keep an eye out for that. So I'm going to open the floor to questions now. I do see one here that's asking about whether or not you can puncture geomembrane liners underneath the system. So that's going to be your choice. If you do need the impermeability of that geomembrane liner, you can use the GEOWEB system to protect the liner and use that tendon and deadman anchorage system so that you're not puncturing the liner in any way and the GEOWEB system is still protected. If you don't mind that the geomembrane liner is punctured, if you don't need impermeable layer there, you can use stakes and go through the liner. That's going to be up to you. Whatever you need for your site, we can give you the appropriate solution. Another common question that we do hear is about turbulent flow especially with aggregate infilled channels. If you know that you're going to have a lot of turbulent flow and you're concerned about washout, you can add some version of surface protection. If you have topsoil infill, adding a TRM or other sort of ECB would be a good way to protect against turbulent flow. If you're using an aggregate filled channel, you may be interested in using something like a rock net across the top to hold the stone in place, or providing some sort of low strength, high flow grout, which would also hold that stone in place. Or you can go with a concrete filled channel, which is going to protect against any version of turbulence that you may see without needing any additional material on top. One more question that's come in is going to be about fines within an aggregate material. If you have an aggregate that you're hoping is going to allow permeability, so allow that water to flow down into the groundwater system, perhaps it's a stormwater relief channel, you want to limit the amount of fines within your aggregate. The more fines you have, the less permeability of the stone. So again, that's something that's going to be based on your project needs and your site regulations. You let us know what those are, and we can help provide that good solution for you. So that looks like all of the questions here today. Thank you all so much for joining us. Thank you, RH Moore, for putting on this webinar. If you have any questions in the future, please feel free to reach out to either myself or RH Moore. Thank you very much.